Hey, I'm Dianna, you're watching Physics Girl, and you're about to see me challenge the CEO of YouTube with some physics riddles. Since we were at YouTube headquarters filming some stuff for International Day of the Girl, she very graciously agreed to answer some riddles. I will make it clear where you can pause and think about the riddles for yourself. You should. I made Susan do it. I am here at YouTube headquarters with Susan Wojcicki. Did I say it right?
Yeah, you said it right.
You nailed it. Susan is the CEO of YouTube, but I am roping her in for some riddles.
So I heard you roped my sister in.
I did. I got your sister on the show.
Yes, and so since she did it, I thought maybe I should do it.
Do you have a little competitiveness there? Is there a little bit of sister
Just
rivalry?
just a little bit.
Just a little bit. I just want to sneak a couple quick questions for my audience, and some of them, a lot of them are students, a lot of them are studying. So I look up to you. I look up to.
Thank you.
It's true. I look up, I have my role models that I look up to. I'm curious who you go to for help or who you've gone to in the past.
Well, it depends, I guess, on like what area of help I need. Like if I look throughout my career and like throughout my life, it would probably be my parents. I know that sounds kind of cheesy, but they would be my parents. And
I think it's all of us, yeah.
All of it. A lot of us go to our parents,
Yeah.
right? Or someone who acts like a parent for us. I can also say, while we're here, actually my childhood idol, and in many ways she's still really, I think an incredible woman in every way, was Marie Curie. Since I'm on Physics Girl channel right now, I need to mention that.
Yes.
She was an incredible scientist. She won Nobel Prizes in different fields. Her daughter won a Nobel Prize. And so I always just thought she was a really inspirational person.
Yeah,
but I
she
couldn't go
is.
to her for advice. I had to go to
Not
my
at
mom
this
and my
point.
dad.
Unfortunately.
Like everybody else.
Okay, let's do the riddles. Okay.
Okay.
Are you ready for this?
Yeah, I am.
Woohoo. All right, here's the first riddle. I have a prop for it. I've got a little tissue here in the neck of this bottle. How can we get the tissue out without touching it? Basically, you can't touch it with your hands.
Can I?
Or a tool. No tools.
Can I just check this out for a moment?
Yes,
here?
you can.
Let's look and see what's going on. Well, I could just like turn it over and go like this. There. See? There, it worked. Physics, gravity, it pulled it out.
Outsmarted by the CEO of YouTube.
Okay, I want to do it again.
Okay, so no turning it upside down.
Can I pour water in and then just have it float up?
Oh, interesting.
Well, I could pour water in it and then
Yeah.
pour the water out.
Yeah, but then you
if
would
you
turn
turn
it
it over.
upside down.
So if it were light, like if it were like a little plastic ball, I think it would definitely come out. But this is
This is questionable.
This is
a surefire way to do it right here and now.
well, I do have water right there. Right here.
I feel like you're cheating, but also
Okay.
just more like outsmarting the riddle. It's just a plain bottle, and there's just a.
Oh, hold on, it went the opposite direction. There we go. Awesome.
Yes!
Okay. There we go.
Yeah,
It's out.
You got it out. That was okay. So why did you think of blowing it?
It was like, what else was I supposed to do with it?
Yeah.
Yeah, but it was weird that it started to go, like I thought it would go in.
Yeah.
And somehow it went out. I don't know why. Can you
Yeah.
explain that to me?
Yeah, I would love to explain
Okay,
that too.
yeah.
Yeah. Like if you're blowing air in there, some has to come out. You're blowing air into the bottle, but there's already a lot of air in there. So that gets pushed out, forming a messy sort of U-turn shaped stream of air. The tissue gets caught up in that and flies out. But the tissue doesn't get that far in the bottle and then circle back out because most of the airflow happens close to the mouth of the bottle because it's like a crowded room in there. Imagine even more people trying to push in through the door. People close to the exit will get pushed out, but you probably won't affect the people far in the room too much. So while the tissue might get initially pushed in a little bit, it'll get pushed right back out.
Wow, that was very interesting.
That was great, yeah.
Okay, good.
The pound it for that
It very
one.
surprised me. It really surprised me. It went the opposite direction than I expected.
Riddle number 2. Are you ready?
Yeah, maybe.
These are batteries, but we're gonna use our imagination and pretend that they're 2 iron bars, both identical.
Okay.
One of them is magnetic and one of them is not. They have the same weight, the same size. You go into a room and you have to figure out which one of them is magnetic.
So one of them is iron and one of them's magnetic?
Well, they're both iron, but one of them is magnetized.
Okay.
Yeah, so they look identical, they have the same feel, same touch, same weight, same density, everything. You go into this room, you don't have anything else metal that you can try sticking them to, and you have to figure out which one is the magnet.
Okay.
So,
so if one was magnetic, it would go, right?
Yeah, but they would stick to each other.
And so I wouldn't necessarily know.
Yeah.
You wouldn't know which one's actually causing the force.
Exactly. Yeah. This is a trickier one than the bottle. This is the kind that people like thinking about for a while.
This is the one I'm sure my dad would be able to figure out.
Your dad would like this one?
Well, I'm sure he'd figure it out, because I have to think this has to do with some properties of magnets.
Do you want me to give you like a hint on some specific tools that would help?
Sure.
Okay, you have at your disposal some string, a mallet, a file, like anything you would find in an office drawer.
Isn't the mallet metal?
Yeah, but like imagine that it's not magnetic metal, because
Yeah.
there are some metals that don't stick to magnets.
Yeah.
Yeah, so imagine it's made of like something not magnetic but is still hard. Maybe it's like a rock mallet and a diamond file so that it doesn't stick to a magnet.
Okay, does it have to do with breaking it in two? Okay. Okay, so let me like break them in two.
Okay.
Oh, I know. I break them in two, and then when I break them in two, then I suddenly have two pieces. And so I can tell which pieces are attracting each other or not. Now it's possible that I could have two pieces that are not magnetized. I put them together and nothing happens.
Exactly. From the if you just
So
break
just
the
going
iron
from
bar.
2 to 4.
Yeah.
Okay,
yeah.
so yes, okay, all right, yes, use a mallet. Break it in two, and then put two pieces together and see what happens. And then put another two pieces together, and then from there I can figure them out. Ideally, like probably I would have labeled them, right? Magnetic, not magnetic.
yeah, okay.
So, but I could
We're
always
in an office, you have a pen. Yes.
Okay, but I could always go back and reconstruct.
Or we're in
which
YouTube,
pieces.
you have a label maker.
Okay, okay, yes.
Here's a challenge for you at home. It's really hard to break iron and we don't know how thick the bars are. So if you can't break them with the mallet, how else could you tell which is the magnet? Let me know in the comments, and I'll leave a comment a day after this video goes up with all the ideas I have and some of the top ideas you write down below in the comments for how you could do this.
Yes.
Good.
Thank
Okay,
you so much.
sure,
That was
sure.
super fun.
Sure, well
Okay.
thank you. That was lots of fun. I agree, that was really, really fun. I enjoyed it a lot.
I
so.
appreciate that you took time out of your incredibly busy schedule to answer ridiculous physics riddles on Physics Girl.
Thank you, it was a lot of fun.
It was great to have you. Thank you so much for watching, and
Happy physicsing!